Good day, students. Welcome to FMT3701. Once again, our new year has begun. I'm your lecturer for FMT3701. My name is Dr. Tebogo Mampane. Anytime you have a problem, please feel free to email me on the email address provided in the tutorial guide. Our lesson for today will start with me just welcoming you and telling you who I am, what the module is about, what assessments are required, what you're supposed to submit, the exams, and the participation that you're supposed to show. Let me start by telling you who I am. I'm Dr. Mampane. I work at the Simon Nkwana Radipere building. My email address is the one stipulated in the tutorial guide. Anytime you have a problem, please feel free to share or contact me. I do respond to students timeously. What you need to know about the content is what we'll be covering is mathematics teaching for foundation phase educators. We need to know the theory behind teaching, how to be a well-prepared teacher, how to be a lifelong teacher, and how to make the lessons fun during mathematics, and also how to maintain discipline and include everybody in your lesson, meaning that your lessons must be inclusive of gender, of race, and of different cultures. So now we're going to focus on the fact that we want to be the best math teachers in foundation phase. These are the things that you need to take note of on a conscious basis. You must know your content. You must be prepared for class, meaning that you must have lesson plans. You must be prepared in the sense of understanding your students, the way they learn, what you're expecting them to achieve at the end of the day, and how the lesson is going to be run. You also, by knowing your students, you know what type of lesson you're going to be presenting. Is it going to be teacher-centered or is it going to be learner-centered? Are you going to be the main role player or are the learners going to be the main role players? When we teach mathematics, try and make mathematics as interesting as possible, meaning that use things that children can relate to. We do that by using real life situations and making the lessons fun. Make your lessons fun by making yourself an approachable maths teacher, while at the same time maintaining discipline. Now, let us start by understanding what it is that you're teaching. Obviously, we're teaching mathematics, but what is mathematics? Mathematics is an area of knowledge that includes the topics of numbers, formulas, related structures, shapes, and spaces in which they are contained, and the quantities and their changes. These topics are represented in modern mathematics with the major disciplines of number theory, algebra, geometry, and analysis. Respectively, there is no consensus among the mathematicians about a common definition of what mathematics is. Now let us look at examples of how mathematics can be used. Every time you use mathematics, you need to relate it to how it's going to be used. Learners always need to understand, why do they need to understand mathematics? Why do they need to be taught mathematics? Where are they going to use it? So most mathematical activities involve the discovery of properties of abstract objects and the use of pure reason to prove them. These objects consist of either abstraction from nature or in modern mathematics. They involve entities that are stipulated to have certain properties called axioms, a proof that consists of a succession of applications of deduction rules to already established results. These results include previously proved theorems, axioms, and in case of abstraction from nature, some basic properties that are considered true starting points of the theory under construction. Where do we use mathematics? Mathematics is essential in natural science, in engineering, in medicine, in finance, in computer science, and social science. Although mathematics is extensively used for the modeling phenomena, the fundamental truths of mathematics are independent from any scientific experimentation. Some areas of mathematics, such as stats and game theory, are developed in close correlation with their applications and are often grouped under applied mathematics. So other areas are developed independently from any application and are therefore called pure mathematics. But often later, we find that we use a lot of practical examples when applying mathematics. Now, the way I've taught mathematics is at the level of students that are teaching mathematics. But if I was to deliver that content to students that are in the foundation phase, let's be honest, that would be very boring. You need to address your audience according to the level of understanding, the way you know your students, the learning styles that they have. So we need to use the right knowledge. We need to use the right language when we're speaking mathematics, because we were trying to address a certain audience. When you're addressing your audience, make sure that you know your audience. Who are your learners? What are you trying to achieve with your learners? And when you find that, it's easier for you to bring across mathematics in a more understanding tone to your learners that you're delivering to. Do not bore your learners. So what are the things that we need to consider to make the lesson fun and interesting for foundation phase mathematics? First of all, yes, it needs to be fun. What makes it fun? You need to understand the level of theoretical concepts that we're going to be dealing with, how the learners learn. Learners learn in a way that makes fun and is understandable to them, meaning that they move from concrete to abstract. So most of the things that you'll have to be doing in a maths class is letting them do touch, feel, see, use their senses, jump up and down, but they must be learning mathematical concepts in the journey of exploring and doing and touching. When you deliver the mathematical concepts, it must be pitched or delivered at the correct level. Use a language that learners understand. It must use real life context. It must be engaging. And most importantly, it must be correct and it must be inclusive, meaning that everybody in the class feels included in whatever activity that you're doing. You can have posters up of different races. You can have use different senses. If children are more visual, then you use more visual charts and more visual things when doing mathematics teaching. If your learners are more abstract and quiet, then you give them more sums to do and give them opportunities to practice further with homework. But you must use a multifaceted approach when teaching. You must use different learning styles to accommodate the different learners. So the following are some reasons that could contribute to the negative attitudes that learners have towards mathematics. First of all, they think mathematics is boring because the teacher does not use resources, there are no opportunities for exploring, and the maths is too abstract. Remember, we need to bring it down to the level of the learners, meaning that we need to move from concrete, using pictures, and then to the abstract. If maths is irrelevant and not contextualized, learners do not identify with what it is that you're teaching, and that becomes boring for them. It needs to be in an appropriate teaching strategy for learners. Teachers can prevent such negative attitudes by allowing learners to make mistakes, develop concepts from concrete to representational, meaning pictures, and then on to abstract. There needs to be a well-developed movement in your teaching. You need to use appropriate teaching strategies. Decide whether this activity requires you to be more teacher-centered or is it one that requires you to be learner-centered. Understand how children develop cognitively. And you also need to accommodate the diverse needs of your learners. You need to use different teaching resources effectively. Mathematics, if we try and summarize it in simple terms, it's a language that makes use of symbols, notations for describing numerical, geometric, graphical relationships. It is a human activity that involves observing, representing, and investigating patterns and qualitative relationships in physical and social phenomena between mathematical objects themselves. It helps to develop mental processes that enhance logical and critical thinking. It helps to also enhance accuracy, problem solving, that is going to ultimately develop you in your decision making. Why do we need to teach mathematics? If children need to understand why it is that they need to understand mathematics, because this question is often asked by learners. Mathematics offers a way of understanding of the world around us. It provides a stable network of symbols through which we can model real-world situations and solve problems. Maths contributes to the subject, for example, the patterns, principles, and procedures. These are useful in technology and science, in arts, history, and geography. Maths also contributes to intellectual development of the learner, namely in problem solving, deductive and inductive reasoning. Deductive reasoning means one systematically and logically reasons out and comes to a conclusion. Inductive reasoning means that one can, through creative thinking, come up with a possible solution. Next, we're going to turn our attention to what are the big ideas when it comes to mathematics that we need to be focusing on. So these big ideas are the ones that are going to contribute to deep learning of mathematics. If we get to the nitty-gritty of teaching mathematics, the choices that one has to make are, when I get into the classroom environment as a teacher, first of all, if I'm going to use the child-centered approach, it means that learning is underpinned by constructivist theory. It means that the child is the active constructor of knowledge. The teacher is only the facilitator. She's going to encourage learners with active exploration, peer interaction, help them in decision-making. But when we come to the teacher-directed approach, this is the approach that holds the view that skills and knowledge is acquired through direct teaching and instruction. The teacher is the one that provides the information. The teacher teaches in small groups or a whole class. The teacher is the one deliberating the teaching skills, the rules, the small steps that are going to be used. And the teacher does not emphasize social skills and peer interaction. At the beginning of every lesson, when a new concept is being taught, the best approach is to use the teacher-directed approach. This is where children are supposed to be quiet, focused, and listen to the steps that you're going to teach. After you have explained everything clearly to them, then you give them a chance to explore what it is that you have taught. So now, let us compare the two between teacher-centered and learner-centered teaching. When we look at teacher-centered, who gives us the knowledge? When it comes to knowledge construction, the knowledge is transmitted from the teacher. But in child-centered learning, the child constructs their own knowledge from doing. Let us look at the role that the teacher is going to play in teacher-centered. The role is that in teacher-centered, the teacher is going to have full authority. They are the leader, and all the children are going to listen to what the teacher is saying. But in a child-centered classroom, the children are the main role players in the class. The teacher only acts as a facilitator. Remember, do not get this confused and say, because the children are the ones that are taking the main role, now this allows you as a teacher to sit back and do nothing. You still, as the teacher, have planned out the lesson. You still, as the teacher, are going to guide them through asking questions and guiding them and seeing that they are getting the answers correct. So that when you see that they're going wrong, you give them questions and ask things such as, do you think that when you add a small number to a big number, it's going to get smaller? As you're listening to the conversations of children as they're playing around and doing activities that you've planned out, if someone is coming up with a smaller answer, you need to explain to the learners and intervene in that role. So now, what kind of participation is going to be taking place? In teacher-centered learning, let us look at what kind of learners we are expecting. In the teacher-centered class, the learners are passive, meaning that the learners are quiet. All the focus is on the teacher. The learners are not doing anything except listening to the teacher, looking at the board, and looking at the steps that you're going to be writing. In child-centered learning, the learners are the ones that are actively doing. They are the ones participating. They are talking, they're actively touching, doing things. When we come to assessment, in a teacher-centered classroom, there is limited assessment that is used for it's only for progression or promotion. The assessment is mainly through written work. But in child-centered classroom, the teacher just observes, there's oral observation, sometimes even a written task that they're going to do. And the assessment is continuous, it's ongoing. As you're observing the learners, you're giving them feedback through the learning process. So the emphasis here in a teacher-centered classroom is that they are learning the correct answers. But in a child-centered classroom, the emphasis is to get deeper learning. Let us begin with our first theories of development. That is our unit 1 that we're going to be focusing on. In this learning unit, we're going to be focusing on just 3 important development theorists and their influences on teaching and learning of mathematics. The theories give us an understanding of the milestones that children achieve at certain ages, which in turn will assist us to understand how mathematics is learned at the different ages or stages. We look at the cognitive theory of Piaget, Lev Vygotsky, and Jerome Bruner. If we begin by Jean Piaget maintained that children's learning is a continuous process of constructing knowledge. He believed that children acquire information by interacting with objects, ideas, and other people. According to Piaget, children construct knowledge through 2 processes of adaptation, namely assimilation and accommodation. Assimilation happens when children add new information to their existing thought structures. In other words, the new information or experience fits in with what they already know. Accommodation takes place when children make changes to their existing thought structures so that new information from the environment can fit in better. Piaget proposed a series of stages through which intellectual maturity moves. He claimed that these stages are fixed and follow each other, but accepted that there was no fixed time for each stage. Piaget suggested that children proceed through stages of development, and these stages are the same for all children according to their ages. Now, if you want to get a summary of an understanding of Piaget's theory, here is just click on the link there at the bottom, https://youtube.b/YKHKXIHWWG8, and it shows a quick video of the summary of what you need to understand when it comes to Piaget's theory. When we look at the social constructivist theory of Vygotsky, on the other hand, Vygotsky focused on the importance of language in learning. According to him, children make sense of their world through shared experiences, and learning occurs in the zone of proximal development. The ZPD encompasses the difference between what a child knows and what a child can learn with the assistance of a more knowledgeable, either than a peer or an adult. In this social interaction, the child learns significantly more and learns deeper concepts than he or she would on his own. Scaffolding is a process through which a teacher adds support for learners in order for them to learn and master tasks. The child builds on the learner's experience and knowledge as they are learning new skills. If we look at Vygotsky's theory, I want you to download this video and have a quick watch. The video should not take more than 5 minutes. All the videos are less than 5 minutes. Go through the videos and just have a deeper understanding of what is going to be asked both in the assignment and in the final exam. So now let us remember that understanding the learning environment is very important for you as a teacher when delivering and teaching. Every child has a unique cultural, historical background that affects how he or she learns. Teachers need to be aware of learners' background and make provision for it in their teaching. The environment must allow for collaborative learning. Children should be seated in a manner which allows them to engage with one another. Remember, there are different ways of seating arrangements. You can do the horseshoe method. You can do individual seating, or you can do a circle where the teacher sits in the middle and they share ideas. The learning environment must be set up to provoke cognitive challenge. That is to encourage children to go beyond what they can currently do on their own. Lastly, our theorist that we'll be focusing on is Bruner. Jerome Bruner, born in 1915 up until 2016, believed that children learn by actively engaging with the environment, but they require guided assistance. That guided assistance we call scaffolding. This enables them to learn optimally. According to Bruner, learning is an active process in which learners construct new ideas or concepts based upon their current and or past knowledge. A learner selects and transforms information, constructs concepts, and makes decisions, relying on a cognitive structure or a schema to do so. The following principles that underpin Bruner theory have implications for teaching and learning of mathematics. If you want to look at a quick video and get a better understanding of the Bruner theory, here's the link that you should go on. Just get a better understanding so that once I ask questions and we start applying, because this subject is more application. Yes, we do the theory. Yes, we do the steps. Yes, there is still the concepts that are being taught, but you need to know how to apply it. If we do a comparison of Piaget, Vygotsky, and Bruner, if we look at how they view the socio-cultural context, Piaget had little emphasis on socio-cultural factors. Vygotsky, on the other hand, had strong emphasis on socio-cultural context, and Bruner also emphasizes social-cultural context. If we look at the constructivism of it, Piaget looked at cognitive constructivism, how knowledge is constructed in the mind. Vygotsky, how knowledge is constructed through interaction. And Bruner, also how knowledge is constructed through interaction at a more deeper level. So we look at the stages of child development. When we looked at Jean Piaget, he spoke about the universal stages that all children go through: the sensory motor, the pre-operational stage, the concrete operational stage, and the formal operational stage. He believed that children have to go through the various stages before development occurs. Vygotsky said there are no stages of development. A child does not have to wait or much depend on social and cultural stimuli for them to grow. That there is something that the child knows, and that gap is the zone of proximal development, moving between the gap of not knowing to knowing. Bruner, on the other hand, spoke about inactive, iconic, and symbolic learning. This is the notion of scaffolding. So the key processes that one needs to focus on when we're looking at Piaget is what drives the development of learning. In Piaget, he said that learning is centered. The learner actively manipulates objects to construct knowledge. The teacher's role is to encourage children to explore and to discover. Whereas Vygotsky says that his emphasis is on social nature of learning and the interactions. The more you interact with adults, the more you interact with the environment, it's the more that you're going to learn. So he's saying that learning drives development, and the emphasis is the role of the adult, how the adult interacts with the child. So they interact with their peers and adults and the cultural environment to solve problems. Teachers' role is to engage children in socially organized activities and to scaffold learning, whereas Bruner, on the other hand, emphasizes only social nature of learning. With regards to the role of language, Piaget believed that thought drives language. Vygotsky says that language is the one that drives your thought. Thank you very much. I hope that after you see the videos, we'll have a more interactive lesson in our Unit 2, where now we apply the knowledge of the theories. And after understanding the theories, I think we'll have a discussion forum, look out for the announcements, and participate in the discussions so that you can achieve better outcomes at the end of the year. All the best, my students. Thank you very much.